Okay, so the next section is going to deal with compound angles. Okay, so by compound angles we just mean angles added together and trigonometric identities associated with compound angles. Okay, so if you've got an angle A and an angle B, a compound angle will be A plus B or A minus B. Okay, that's all we mean by compound, just like compounding things, putting them together. Okay, so the first thing we want to do is get a formula for the cosine of A minus B. Alright, the first time you see this, it's going to be like, oh, how am I ever going to remember that? But you will, okay, after doing it 100 times. Anyway. Okay, before we do it, I just want to kind of cast your mind back to that unit circle, and just to remember that if we have a triangle, and we have the hypotenuse, a right angle triangle, the hypotenuse is 1, and we want an expression for this length here in terms of the angle theta. Okay, so if we call this our y and this our x, okay, just like we're giving coordinates, then we want to find x and y in terms of theta. Remembering that our hypotenuse is 1, we know that the sine of theta is the opposite over the hypotenuse. So that's basically telling us that y is equal to sine theta. So this length is sine theta. And cosine theta is equal to our adjacent over our hypotenuse, which is telling us that our x value then is just equal to cosine theta. So from here to here is cosine theta. So if this was my 0, 0 point just here, my coordinate here would be out cosine theta, up sine theta. That was my y-axis and that was my x-axis. Okay, so bearing that one in mind, I'm going to draw the unit circle over here. We've got the unit circle. I'll tell you the plan. Okay, so the plan is, let me see, we're going to take a point here and we're going to take a point here. Okay, now we've just agreed that as long as this is the unit circle, so this is 1 and this is 1, the coordinate of this point here, if we call this the angle B, okay, the coordinate of this is the x coordinate is cosine B, the y coordinate is sine B. We've discussed this before where we've referred to the fact that the height is the sine and the width is the cosine. So as we go along the circle, our sine gets bigger, get to 90, sine gets smaller, gets bigger in magnitude or in absolute value, but is negative, and then gets smaller, back again, and so on. And our cosine, as we go along, our cosine is getting smaller, bigger but negative, and so on. Anyhow, we've done that before, so I'm not going into it in any detail now. Okay, if we call the whole angle here A, so this is angle A, right, then the coordinate of this point here will be cosine A, sine A. Alright? So now, the piece in the middle, this angle here, then hopefully you will see is angle A minus angle B. Okay, A is the whole thing, B is this bit, so this is A minus B. Right, so the plan is, this distance here we'll call x. So we're going to work out a formula for x using the distance formula, and we're going to work out a formula for x using the cosine rule. Okay, so just two ways that we're going to equate both of them. So hopefully you will agree with me that x is equal to the square root of, I'm using the distance formula, x1, y1, x2, y2. The square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So x squared is equal to, and if I multiply these out, cosine squared b minus, oops, hang on a second. Oh yeah, sorry, one of these should be an A. Apologies, that's A here. Cosine squared b minus 2 cosine A cosine B plus cosine squared A plus sine squared B minus 2 sine B sine A plus sine squared A. Okay? So that's one expression that we have for x squared. Remembering though, cosine squared B plus sine squared B, remember our rule, sine squared theta plus cosine squared theta equals 1. So cosine squared B plus sine squared B is equal to 1. And then we also have a cosine squared A plus sine squared A, so that's also equal to 1. So x squared is equal to, so that's a 1 plus a 1, so that gives us 2, minus 2 cosine A cosine B, minus 2 sine A sine B. Okay, so we'll leave that for the moment. We'll go over and look at the other way of getting x. So our cosine rule. Remember our cosine rule? Our cosine rule states that x squared is equal to 1 squared plus 1 squared minus twice 1 by 1 times the cosine of A minus B. Remembering that this is what we're looking for. Okay, cosine A minus B is the expression that we want to find, or the thing we want to find an expression for. Okay, so now we can equate the two of these together. So first of all, let's just simplify that. That's 2 minus 2 cosine A minus B. Okay, so now we can put the two things together. So this x squared, so 2 minus 2 cosine A minus B is equal to 2, I'm not going to fit it, so I'm going to put it down here, is equal to 2 minus 2 cosine A cosine B minus 2 sine A sine B. Okay, so now we've got a 2 on both sides, so we can subtract that from both sides. We can multiply both sides by minus 1 to change the sign, so we get 2 cosine A minus B is equal to 2 cosine A cosine B minus 2 sine A sine B. Okay, I think we can rub this bit out now. Okay, divide everything by 2, both sides. Cosine A minus B is equal to cosine A cosine B minus sine A sine B. And that is in your log tables. And you definitely have to be able to prove that, and you can be asked to prove it. Okay, so that's a very important one. Now, it doesn't take much more to find the expression for the cosine of A plus B. Okay, because if we think about it, the cosine of A plus B, we could agree is the same as the cosine of A minus B. Okay, and we have an expression for the cosine of one angle minus another angle. So if we know what the cosine of A minus B is, then the cosine of A minus B just means we're going to put a minus B everywhere we see a B. So that's equal to cosine A cosine minus B minus sine A sine minus B. Okay? Now that leads me to another very important fact, which we may have mentioned before, but just in case we haven't. Okay? It is written in your log tables anyway. The sine of A of minus A is actually minus the sine of A, and the cosine of minus A is actually just the same as the cosine of A. Okay, now one way to look at that is if I draw the sine graph. Not fantastically drawn, but now if this is, let A be any angle, so if this is A here, okay? Then we want to know what the sign of minus a. So we go exactly the same distance the other way. And since the sign is symmetrical, it's exactly the same distance, but you can see that it is minus the sine of a. Okay? So the sine, this is our sine function. So the sine of a, the sine of minus a rather, so if we're out here at minus a, okay, the sine of minus a is exactly the same value, but it's minus the sine of a. And similarly with the cosine, if you look at the cosine function goes like this. So if you look, the cosine of a is exactly the same value and the same sign as the cosine of minus a. Okay? So that's where this comes from, but it's in your log tables. Important to remember. Okay, so from there, let's just finish that then. Okay, so the cosine of a plus b, effectively there, is equal to cosine a, and we just said the cosine of a minus number is the same as the cosine of the positive version, minus the sine of a times minus the sine of b, because we agreed a minute ago that the sine of a minus angle is actually minus the sine of the angle. Again, it's in the log tables. So what do we get then? We get cosine a, cosine b, and a minus multiplied by minus plus sine a, sine b. And that's the expression for cosine a plus b. Again, fully examinable in the leaving cert. Okay? And pause that.